Hello, everyone. My name is Peter Cartmel, and I am the platform manager at Galvanic. Today, we have an application training for the olefin industry. We will be discussing how to optimize online measurement specifically for catalyst protection. Olefins are unsaturated hydrocarbons. The hydrocarbon processing sector produces the feedstock used for the olefin production. Some of the most common feeds are ethane for ethylene production and propane for propylene production. The table on the right highlighted examples of olefins, but ethylenes and propylenes are probably the most common. Various industry methods are used to manufacture olefins. Steam cracking is a technique used for both ethylene and propylene production. After the olefins are manufactured, they are often used as feedstock for polyolefin production. Polymerization is a common technique used for both polyethylene and polypropylene production. Here we have an example of a process flow diagram for how a steam cracking plant operates. Ethane is diluted with steam and briefly heated in a furnace around 850 degrees C. The gas is then quenched to stop the reaction in the heat exchanger or inside a quenching header. Every few months, operators must decoke the reactor walls to avoid reducing efficiency. Another area of the process control that the operator pays close attention to is the catalyst condition. Each plant uses a different catalyst based on the reactor design and conversion rate for optimization. Feedstock inevitably contains impurities such as arsine and phosphine. These impurities accelerate catalyst depletion, which increases the frequency of replenishing the catalysts. This drastically increases the plant operation costs, approaching $1 million. Impurities can also contaminate the final product, which risks losing business upwards of $1 million. Here we have an example of a process flow diagram for an olefin plant. Each plant uses a different protective measure to minimize impurity in the feedstock. Operators often monitor these impurities at various points in the plant. How do you measure your catalyst condition to identify excursions? Are you trying to reduce the frequency of how often you need to replace your catalyst? If so, we recommend considering a tape analyzer to successfully monitor your catalyst conditions. These are process gas analyzers that can be configured to monitor several impurities in your catalyst. This includes arsine, phosphine, phosgene, chlorine, H2S, and total sulfur. These techniques measure impurities with 5 ppb sensitivity, which rivals laboratory performance. Analyzers can also be configured to monitor multiple streams for a fast return on investments. Tape analyzers follow the ASTM method, suitable for wide ranges of gas sample. These analyzers can monitor the normal working range in the low ppb. They can also measure in ppm range for reporting purposes. Here's a process flow diagram showing how tape systems work. The configuration includes a sample inlet and sample sweep. Then there is pressure and flow regulation followed by DI water humidifier. The optic block performs the measurement and then the gas goes out the vent. The analysis sequence is based on the rate of change of the stain on the tape. When the impurity, such as arsine, comes in contact with the tape, a stain forms. The rate of change is proportional to the concentration. Tape analyzer uses a fixed time analysis to monitor the desired impurities. A pulse counter is used to maximize tape life by reducing the space between each analysis stain. The analyzer software includes a predictive alarm. Even though the analysis sequence is 3 minutes, this will alert the DCS of any issues in less than 30 seconds. Galvanic's ProTech Nano 3 is our 3rd generation tape analyzer, marking 30 years of field experience. The analyzer can be installed in a shelter with sample conditioning. We also include an H2S scrubber to make sure that there's no interference monitoring arsine and phosphine. A unique offering includes with the ProTech Nano 3 is an onboard calibration. We eliminate the needs for calibration cylinders by the use of a G-Cal or a G-gas generator mounted inside the analyzer panel. A small volume of analyte permeates and mixes with the carrier gas when calibration is required. This ensures streamlines hands-off operation of your analyzer. The ProTech Nano 3 tape analyzer is designed to provide measurement certainty to your process. By continually monitoring your catalyst for impurities, we guarantee a rapid return on investment. Our analyzer will detect impurities down to 5 parts per billion every 3 minutes with an alarm every 30 seconds. We have 40 years of experience in the hydrocarbon processing industry using a variety of technologies. We are confident that the ProTech Nano 3 will serve you well. Thank you for joining us to learn how you can optimize your olefin units with an online tape analyzer. If you have any questions, please contact the Galvanic sales team. You can also reach out to myself, Peter Cartmel, and as always, you can contact your local authorized distributors. Thank you and have a great day.